What I want to do in this little video is to show you how we want to use the distributive law with dot product the same way we use the distributive law with polynomials. So recall, with polynomials, how we multiply something like 2x plus 3y times 5x plus 7y. Now in algebra class they say FOIL, but FOIL is not one of the properties that actually define the real numbers. There's nothing like it. What we do have is a distributive law. Now what we actually did when we first started doing algebra, as we remember the distributive law, let's call this whole big thing here A, and this whole thing over here B plus C. And then the distributive law would say we should get something like AB plus AC, like that. So the distributive law, not FOIL so far, says I should get A, which is 2x plus 3y times 5x plus 2x plus 3y times 7y. And now you can see we're in a situation where we can just use the distributive law again. So this should be 2x times 5x plus 3y times 5x plus 2x times 7y plus 3y times 7y. Like that. And you can see this is actually identical to the formula we would get for FOIL. But FOIL is not a property, but using the distributive law twice is. Very, very important. We can, as long as we have a distributive law, we can multiply things like 2x plus 3y times things like 5x plus 7y. Now, let me show you how I would do this for dot product if we had a distributive law. So let's put a little asterisk here because we don't have a distributive law yet, and I would want to calculate just going to change a little bit. I want 2i plus 3j dot 5i plus say 7j. If we had a distributive law, and that will be the next video is coming up with a distributive law, we could do exactly the same thing before, right? This would be the A vector, this would be the B vector plus C vector, and we could just distribute. Well, I'm going to just distribute. So I'm going to get 2i plus 3j dot 5i plus 2i plus 3j dot, and that's not multiplying anymore, that's dot product, 7j. And if we have a dot product distributive law, we could keep going. So I'm going to get something like 2i dot 5i plus 3j dot 5i, and see over here, plus 2i dot 7j plus 3j dot 5i. So actually I think we've successfully at least dotted them all. These actually wind up being a lot cleaner and a lot easier than you might think. Let's put equals, I guess, over here, and we'll just see what we can do with this, right? Remember that 2i and 5i are parallel in the same direction. So their dot product is just the product of their lengths, like that. Remember that j and I are perpendicular. That makes 3j and 5i still perpendicular, so that's just equal to 0. 2i and 7j are still perpendicular, so that's just equal to 0. And now what we're going to get is 3j, this should be 7j. That should be 7j. What am I going to get? I'm going to get 3 times 7. Like that. Sorry about that. Meanwhile, that does say if we have the distributive law, we can actually calculate the whole dot product. Now, I'm going to write this as this conclusion as in column form so you can actually see what's going to happen. So what we had, I'm going to leave the answer down here, and I'm going to write the conclusion of our calculation like this, conclusion. If I take the vector 2, 3 and dot it with the vector 5, 7, according to what I have down here, I get 2 times 5 plus 3 times 7, and you can see that it looks like we're just multiplying across and adding. So it's going to be 2 times 5 plus 3 times 7. That's going to be a general property that's going to work, but it all follows from the distributive law. So in the next video, what I'm going to ask you to do is to calculate this. Say A times I plus B times J plus C times K dot. How about D times I plus E times J plus F times K. You're going to have to use the distributive law a lot, but you're going to get a lot of zeros and you get a nice property, and when you write it down using columns, it'll come out nice. And so that's the next activity, is for you to calculate this using the distributive law that we don't have yet.